hexamethylene diamine, and this type of acid adipic acid with n number combined to form. Here what we separated, we get NH, CH2, 6NH, CO, CH2, 4, CO. What is that n number of molecules? So this is example for what is example? It is called as a nylon. This is nylon 6 and 6, nylon 6, 6. So when you compare these two, first compound monomer units are same, but second compound monomer units are different. First compound formed by without losing of any type of water molecules or any molecules, but second polymer is formed by losing of some water molecules. So it is called as a homopolymer, and it is called as a copolymer. Homopolymer means monomer units are same, that is called as a homopolymer. If monomer units are different, that is called as a copolymer. Monomer units same, that is homo. Monomer units different, that is called as a copolymer. So homopolymers, and this is also called as a addition polymerization, and it is called as a condensation polymerization. So addition polymerization, second one is called as a condensation polymerization. So again here polymerization is two types, addition and also condensation polymerization. Addition means monomers are simply added. Condensation means monomers are formed by losing, polymer is formed by losing of some molecule. This is called as a what is the condensation polymerization. Next one is called as a classification of polymers. First is classification of polymers. First classification is based on source. First classification is based on source. So based on source, polymers are divided into two types. One is called as a natural, and second is three types here: synthetic polymer, and third one is called as a semi-synthetic polymer. So based on source, polymers are three types: natural polymers, synthetic polymers, semi-synthetic polymers. So these natural polymers are generally obtained from plants and animals, that is called as a natural polymer. So these are obtained from plants and animals. Example, cellulose. Example here we write cellulose. Synthetic polymers are you prepared in laboratories. Laboratories from carbon compounds. So one example for this is nylon 6,6. Semi-synthetic polymer contains both natural and also synthetic polymer units. Example, this is the nitrocellulose. So based on source, polymers are divided into three types: natural polymers, synthetic polymers, and also semi-synthetic polymers. Next classification is based on, second part of classification is based on structure. So based on structure, how polymers are classified. First one is linear polymers. Second one is branched chain polymers, branched chain, and third one is cross-linked or three-dimensional. Cross-linked, three-dimensional, or we can call it as a network polymers. So based on source, polymers are divided into three types. Linear polymers. What is the next is the branch chain polymers. And the third one is called cross-linked or three-dimensional polymers. In first one, in linear polymers, so one monomer unit is arranged over other monomer unit. One monomer unit is arranged on other monomer unit. In between this, because of large surface area, in between monomer units, attractive forces are more. And what is that? It is a high tensile strength. This polymer generally contains high tensile strength because of this property. And what is example for this polymer is nylon 66. Nylon 660 is example for linear polymers. Second one is called as a branch chain polymers in between monomer units. Some branches are present and these branches are not in a proper size. Because of this improper arrangement, this polymer shows low melting points and boiling points. And tensile strength also less. Example, starch or glycogen, which is present in animal cells. These are example for what type of polymers. Second one is called as a branch chain polymers. Third one is called as a cross-linked or network polymers. Here, these monomers are arranged with a proper side chains. These are arranged in three-dimensional way. These are called as a cross-linked or three-dimensional or network polymers. So, because of this proper three-dimensional arrangement, branches also in same size because of this what is a three-dimensional arrangement. These polymers are they show high melting point, boiling point values, high tensile strength also. One example for this polymer is bakelite. So based on structure, polymers are divided into three types: linear polymers, branch chain polymers, and also three-dimensional or network polymers. And next one is based on attractive forces. Based on attractive forces. Based on attractive forces, polymers are divided into four types. One is called as a elastomers. Second is called as a fibers. Third is called as a thermoplastics. Fourth is called as a thermosetting plastics. Thermosetting plastics. So here, based on attractive forces, polymers are divided into what is that? This type of polymers are formed. First one, what type of attractive forces present here? They are weak. What type of attractive forces here? Weak electrostatic force are present here. First one, elastomers. Because of this, it shows a one property that is called as a elasticity. it shows one more property that is called low tensile strength. And next is it shows low melting points and boiling points. This is example for elastomers. One example here is natural rubber. One example for elastomers is natural rubber. Okay. Next is fibers. Second one is the fibers. So what type of attractive force are present in fibers? Generally intermolecular hydrogen bonding and dipole bonds also present. Because of this intermolecular hydrogen bonding and dipole attractive forces, fibers have high melting points and boiling points, and the main property is high tensile strength. This is the main property, high tensile strength. One example for this is again nylon 66 is example for this type of polymers, fibers. And third is called as a thermoplastics. Thermoplastics. So what type of attractive forces are present in thermoplastics? The weak attractive forces that are van der Waals force are present. And these thermoplastics can be regenerated again, can be reused again, because these are soft polymers, low melting points and boiling points. When it is melted, again it is cooled by using of by cooled, and we can change into desired shape. It is melted again when it is cooled. Again, it gives a solid substance, so we can convert into desired shape. We can be reused again and again. An example for thermoplastics that is called as a polythene. And the fourth type of polymers are called as a thermosetting polymers. Generally, these are example for three-dimensional or network polymers. This thermosetting polymers, they show high melting points, boiling point values, high. What is that? Cannot be reused again. We can prepare one time only. When it is heated, it gives a black color substance. So it cannot be reused again. So what type of example? These are very hard. Bakelite, styrene, melamine. These are example for thermosetting polymers. So this is the classification of polymers based on what is that structure. Sorry, based on attractive forces. Polymers are divided into four types: elastomers, fibers, thermoplastics, thermosetting plastics. Next is the different types of, we'll discuss about different types of polymers. First, we start with the polythene. Many number of ethene molecules are combined to form what is that it is polythene is formed in this reaction. Many number of ethene molecules. So polythene is two types: low density polythene. And next one is called as a high density polythene. So two types of polymers are there: low density polythene and high density polythene. Here some 373 Kelvin temperature is maintained for 373 Kelvin temperature is maintained up to for this high density polythene preparation method. And also we use a 6 to 7 atmosphere pressure for high density polythene. And we use a catalyst like Ziegler's Natta catalyst also used in preparation of high density polythene. So what is this Ziegler Natta catalyst? Titanium tetrachloride and triethyl aluminate. This is called as a Ziegler-Natta catalyst, and this is prepared more than 573 Kelvin temperature. We maintain 62, some 70 atmosphere pressure also we maintain, and we get a low density polythene. So low density polythene is transparent in nature. High density polythene is not transparent. It is also called translucent. So both are hydrophobic, repel water molecule. So what is the use of low density polythene? This is used for insulation of electric wires. So low density polythene insulation of electric wires, and also what is that in electric wires? It is used, and also squeeze bottles also it is used. Squeeze bottles, and also flexible water pipes and carry bags also. What is that low density polythene is used. So what is use of this high density polythene? High density polythene is used in preparation of buckets. It is used in preparation of mugs. It is used in preparation of toys, and also in dustbin trays also. For preparation method, high density polythene is used. So this is the first type of polymer, high density and low density polythene. Next type of polymer is polytetra polytetrafluoroethylene. Second type of polymer. This is the polytetrafluoroethylene. N number of ethylene tetrafluoroethylene molecules polymerized in presence of catalyst. So we use the catalyst. Generally, oxygen is used as catalyst, and we maintain high temperature and high pressure conditions are used. So we get this polymer CF2 with n number of molecules. This is polytetrafluoroethylene. This is called as a Teflon also. So what is the nature of this? It is resistant to heat, and also it is does not involve in reaction with the chemicals. It is does not involve in reaction with oils, and the heat resistance. It shows a some part of heat resistance. So due to these properties, it is used for coating of what is that pans. Teflon coating, that is called coating on vehicles also it is used, and in preparation of gaskets also it is used. So, and also pump packings, gaskets, petrol pump, what is that pump in vehicles, pump packings and gaskets. This is used. So it is a important uses. So what is that? One more is coating on coating on fans also. Fans and nowadays vehicles also it is used. This is the important uses of one more polymer that is called as a Teflon polytetrafluoroethylene. After that, next type of polymers are called as a what is that polyesters. We start with ester compounds are present here. Polyesters. First one is called as a pteryline. What is this pteryline? Here monomer units are ethylene glycol. N number of ethylene glycol. This is ethylene glycol here. Glycol is used, and also one more n number of what type of compound here. This is the terephthalic acid is used in this polymerization method. N number of terephthalic molecules. So what is the polymer formed here? OCH2, CH2. Here water molecules are separated, and CO with OCH here also one oxygen, CO, and this is the what is that benzene ring with the CO O group is present with the n number of molecules. with a number of molecules. So this is called a pteryline, or one more name it is called as a dacron. So what is important use of what is a polymer? It is mainly used in textile industry. So it is blend with cotton, that is called terrycot. So we get the wrinkle-free shirts, terrycot. It is mixed with wool. It is called terry wool. So it is mixed with what is that fibers in textile industry. Because of this, wrinkles decreases, and tensile strength of the fibers also increases. And one more important use is it is used in preparation of magnetic tape recordings also. What is that? Polyesters are used. What is the first type of polyester is Terylene or dacron. Second type of polyester is glyptol. Glyptol, or it is also called alkyd resin. So what are the monomer units of this glyptol or alkyd resin? N number of ethylene glycol molecules with what type of compound? It is called as a phthalic acid. What is that? N number of phthalic acid molecules combined. We get this glyptol. Here, these are the monomer units: CO, O, CH2, CH2, and here also CO, O, CH2, CH2, O, with n number of molecules are involved in this reaction. So what is important use of this glyptol resin? It is example for three-dimensional polymer, or we can call it as a cross-linked polymer. So because of this, mainly it is used in building materials. It is used in building materials like asbestos, and it is mixed with cement also. Cement preparation also it is used, and also it is used in a paint industry also. Paint industry also, this glyptol or alkyd resin is used, and monomer units are ethylene glycol. This is ethylene glycol with phthalic acid. Next type of polymers are polyamides. Polyamides. So we'll take an example. For first type of polyamide is nylon 6,6. So what are the monomer units? N number of hexamethylene diamine combined with n number of adipic acid molecules, COOH here, CH24, COOH, here also COOH, with n number of molecules are combined, adipic acid molecules are combined. And what is that? In this condensation polymer, loss of water molecules takes place. N number of water molecules are lost, and we get this compound NHCH26 NHCO CH24 and the CO. This type of polymer is formed with this reaction. Okay, what is uses of this nylon 6,6? It shows a high tensile strength. It is used in toothbrushes. What is the bristles of toothbrush also? It is used. What is that? It is of next is in textile industry. Textile means innerwear, hosiery, innerwear. Textile industry also. This nylon 6,6 is used. And also, what is that? In car tires also, this is used. Seat belts also, nylon 6,6 is used. These are important uses of this. And next type of polymer is nylon 6. These all are example for polyamides. What is this nylon 6 caprolactam? What is caprolactam? NH with a 5-member ring CH2, 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 CO group. It is heated in presence of water. So we get this compound NH2, CH2, 5, COOH. This is called amino caprolactam. Caprolactam. The cyclic structure is called as the caprolactam. Or we can write 6-amino caprolactam also. This is formed in this and it is heated. So one side H2O, one side H and one side OH group is separated with different monomer units. And we get this compound CH25CO. This type of polymer is formed. This is called as a what is that nylon 6. So what is the important use of this nylon 6? It is mainly used in ropes, fabrics, and also it is used in tight cords also. What is that nylon 6 is used. So this is a nylon 6 and nylon 6 are example for polyamides. Okay. And the next type of polymers are formaldehyde resins. Next type of polymer type is called formaldehyde resins. So first we start with the phenol formaldehyde resin. Phenol formaldehyde resin. This is also called as a, again it is divided into, okay, first we start with what are the, how these monomer units are combined. Phenol plus formaldehyde resin. Phenol is C6H5OH. How many molecules are combined? N molecules are combined. N number of formaldehyde molecules are combined. And this combination is 2 times by losing the water molecule. So these are attached by only side chains. Only side chains it is attached. Only side chains only it is attached, or it is attached by 3-dimensional way also it is attached. So here also one bond is formed here. What is that? Again, one more unit, and it is arranged in a 3-dimensional way also. This arrangement is possible. So if it is arranged in a 2-dimensional way or it is arranged in a 3-dimensional way. So 2-dimensional way, what is important use of this? It is used in 2-dimensional compounds. It is used in paint industry generally. Paint industry mainly it is used. One example, this name is called as a Novolac. What is the name of this polymer formed by 2-dimensional arrangement or linear arrangement? That is called as a Novolac, or it is arranged in a 3-dimensional way. This is also called as a bakelite. What is Novolac? It is used in paint industry. Bakelite. It is hard polymer, 3-dimensional polymer with high tensile strength, high melting points, high boiling points. And this is example for thermosetting polymer. And it is used in, what is that? Generally, it is used in electric goods. Electric goods means switchboards also. What is that? It is mainly used, and also it is used in gramophone records, fountain pen barrels also it is used, and also unbreakable cups and plates. This is the bakelite is used. These are important uses of bakelite. Once again, the difference between bakelite and Novolac is in Novolac, phenol and formaldehyde arranged in a 2-dimensional way. Bakelite, phenol and formaldehyde arranged in a 3-dimensional way. This is the first type of formaldehyde resin, phenol formaldehyde resin, first one. And second type is melamine. Melamine. formaldehyde resin. Second type is the melamine formaldehyde resin. What is this melamine? It is like a benzene ring, but cyclic group. But here alternate bonds with nitrogens are present. NH2 group. This is called melamine. N number of molecule combined with N number of formaldehyde. So what type of polymer is formed here? So this is a polymer formed. This type of polymer is formed here. This side also bond is formed. This side also bond is formed. Here, what is that group present here? CH2 group is present. So this is arranged in a three-dimensional way. Here also bond, here also bond, here also bond is formed with n number of molecules. So this is called melamine formaldehyde resin. Okay. What is the monomer units here? Melamine. This is the structure of melamine. It is similar to benzene structure, but in place of one carbon, nitrogen is present. Again, carbon is attached with the NH2 groups, and one side this NH2 group formaldehyde is added like CH2O by losing of water molecules. This is example for condensation. Here also it is attached with one more group. Here also it is attached with one more group. So it is called three-dimensional polymerization. And what is the nature of this? It is a hard polymer with again it shows a high melting points and boiling points. What is the use of this? It is used again. Main use is unbreakable cups or crockery. It is used. Plates and cups also it is used. Okay. So this is the important use of melamine formaldehyde resin. Okay. This melamine formaldehyde resin and also what is that? One more polymer that is bakelite and novolac. These are example for what type of polymer? These are example for formaldehyde resins. And one more is the next is the polystyrene. What is this styrene molecule? If a benzene molecule, this is called styrene molecule. N number of molecules of styrene involved in polymerization process. So, what type of polymer is formed in this reaction? Here with the benzene ring with n number of molecules, this type of polymer is called as a polystyrene. What is important use of this polystyrene? It is a polystyrene also shows a high melting and boiling points. It is also used in making of unbreakable cups and plates. What is that? This is important use. Next, one more also there, urea formaldehyde resin. One more is urea formaldehyde resin. What is this urea formaldehyde resin? It contains urea molecules, n number of urea molecules, and also n number of formaldehyde molecules are present. And it is example for condensation polymerization because it formed by losing of some water molecules. So we get this compound here, CH2 with n number of molecules what is important, the use of urea formaldehyde resin. It is mainly used in laminated planks. Lamination industry is used laminated planks, and also it is mainly used in glazed tiles. Tile industry, that glazed tiles also this urea formaldehyde resin is used. Okay. And next is the synthetic and natural rubbers. First, we start with what type of rubber is that is. First, we start with natural rubber. So, natural rubber is obtained from rubber plants. It is some tropical countries. What is the natural rubber? What type of polymer is present? It is a white color semi-solid liquid. It is obtained from rubber plants. When trunks are cut, there from the trunks, this what is that? A semi-solid compound, white color compound is formed. So that compound is called as a latex of that rubber tree. That latex contains isoprene units. What is this isoprene unit? CH2 double bond C, CH3. Next, CH double bond CH2. This is called as a isoprene unit. What is this? This is a cis 2 methyl cis 2 methyl 1 and 3 butadiene. Cis 2 methyl 1 and 3 butadiene is called as a isoprene unit. So many isoprene units are combined in polymerization process. What is that? It is CH2 double bond C, here CH3, CH double bond CH2. N number of molecules are combined. Here N number of molecules are combined by addition polymerization, and this compound is formed, that is called natural rubber is obtained here in this combination. Here in this combination, natural rubber is obtained with n number of molecules. Here CH3 group is present. So this is the natural rubber is obtained in this process. And what is nature of this natural rubber? It is the linear combination, and it shows a what type of attractive forces, weak attractive forces. What is that example? It shows a property of elasticity. So it is also called elastomer. And the natural rubber contains a low tensile strength also. And when it is heated, it is melted at low temperature conditions, it becomes brittle in nature. So that is the reason, because of this low strength, its strength increases by mixing with sulfur. How much sulfur is mixed here? Some 3 to 4% of sulfur is mixed by temperature at 373 Kelvin temperature. That process is called as the vulcanization of rubber. Because of vulcanization, in between these monomer units, here, what is that? In between monomer units, some extra bonds are formed with sulfur. Some extra bonds are formed. Because of this extra bonds, what is the nature here? Its tensile strength always increases, and the melting point, boiling point increases, and this elastomer is converted into cross-linked polymers. Because of this extra sulfur bonds are formed between this what is the rubber molecules of monomer units of isoprene. So what is the important uses of this natural rubber? We know that generally it is mainly used in what type of industry? It is used in the preparation of tiles. Also, it is used in tile summer. Tire industry it is used, and also soles of footwear also it is used. So, footwear industry also it is used. So these are important uses of natural rubber. Once again, Natural rubber contains isoprene units. What is meaning of isoprene units? Cis 1,2 dimethyl, cis 2-methyl 1,3-butadiene. This is called as a isoprene units, and here it shows a low tensile strength. So we add 3 to 4% of sulfur is added. But if we add less than that, that is used in preparation of rubber bands. But if you add excess amount, more amount of sulfur, that is called very hard rubber is formed. That is called as a ebonite rod also. So in vulcanization process, strength increases, and this polymer becomes a cross-linked or three-dimensional polymer. So it is used in what is that rubber industry. It is used in preparation of main uses or tire industry. It is used. Next is synthetic rubbers and neoprene rubber. Neoprene. Synthetic rubber. This is example. Synthetic rubber is generally natural rubber is hydrophilic. Any natural polymer is hydrophilic, it absorbs water molecule, but synthetic polymers are hydrophobic in nature, it repel water molecule. So neoprene rubber contains what type of monomer units? This is the 2-chloro-1,3-butadiene. This type of monomer units are present. These are polymerized and it gives this type of polymer is formed here. And number of molecules here combined. This is the neoprene rubber, where it is used, neoprene rubber used in tire industry. Okay, we'll discuss all this synthetic rubber. First type of synthetic rubber is neoprene rubber. What is difference between isoprene and neoprene rubber? In neoprene rubber, instead of methyl group, chlorine is present. So 2-chloro-1,3-butadiene. In isoprene unit, instead of chlorine, methyl group is present. This is neoprene unit, and that is called as a isoprene unit. So first type of synthetic rubber is neoprene rubber. And next is one more is Buna N rubber. Buna N rubber. What is this Buna N rubber? It contains a 1,3-butadiene monomer units. 1,3-butadiene plus acrylonitrile. So what is this Buna N rubber? 1,3-butadiene and also acrylonitrile is present in this Buna N rubber. Vinyl cyanide is only called acrylonitrile. So here N number of 1,3-butadiene combined with N number of vinyl cyanide molecules, and what is the polymer formed in this reaction is here CH2, CH double bond CH, CH2, CH2, CHCN with N number of molecules are formed here. This is called Buna N rubber. What is that uses of this Buna N rubber? It is mainly used in making of oil seal from engines. Oil seals cannot be separated. Oil cannot be separated from this engines, and also for tank lining, some rubber is used. That type of rubber also. That is example for Buna N rubber. Once again, in Buna N rubber, monomer units are 1,3-butadiene and acrylonitrile. After that, next one is called as a Buna S rubber. What is this Buna S rubber? It contains 1,3-butadiene. This monomer unit is 1,3-butadiene plus N number of styrene molecules are used. This is styrene molecules are used. N number of styrene molecules are used in this reaction. And what is the polymer formed here? CH2, CH double bond CH, CH2 with CH with benzene ring, and with a CH2 with n number of molecules are formed in this. What is the use of this Buna S rubber? First is it is used in mainly automobile tiles, mainly made of what is that vulcanization rubber or Buna N rubber, and also tile industry making of floor tiles also it is used. So mainly it is used in tile industry, it is used floor tiles, it is used, and also footwear industry also it is used. And one more is the insulation of cable wires also. Insulation of cable wires also it is used. What type of rubber? That is called as a Buna S rubber. So how many synthetic rubbers are present? Buna S rubber, Buna N rubber, and neoprene rubber, and natural rubber is isoprene rubber. Isoprene units are present in natural rubber. And next is the PVC. This is called as a polyvinyl chloride. What are monomer units of PVC? Monomer units are n number of vinyl chloride molecules. This is the vinyl chloride molecules combined to form polyvinyl chloride, CH, with what is that? Cl. So, what is the nature of this vinyl chloride? Generally, carbon is what type of? What is the nature of carbon? Carbon is hydrophobic in nature, so it repel water molecules, and because of this hydrophobic nature, it is used in, and also it is resistant to electric shock also. So it is used in what is that? Water pipes. Second is it is used in preparation of handbags. Next, it is used in preparation of what type of raincoats also it is used. These are important uses of polyvinyl chloride. One more rubber, polyvinyl chloride. Next is thiol rubber, or we can call it thiol. So what is the monomer units of thiol? That is CH2, CH2Cl. This is vicinal dihalide, ethylene 1,2 dichloroethylene, ethane 1,2 dichloride, plus the sodium tetrasulfide. This type of monomer units are present, and so we get this thiol, or some books it is indicated by thiocol also. So what is the polymer formed in this reaction is CH2, CH2, and here sulfur can form, many sulfurs can form a polymer units. So what is the main uses, or again this thiol rubber is used in tire industry, it is used, and also in tire coatings also that thiol rubber is used. The next is polypropylene. So n number of propene molecules, n number of propene molecules combined to form in presence of peroxide catalyst, high temperature and pressure conditions. So in this reaction, polypropylene is formed. So this is the polypropylene. N number of molecules are combined. What is uses of this polypropylene? Polypropylene used mainly for what is that? It is used in manufacturing of ropes. The ropes are important for trekking of mountains, and it is used for packing material also. Packing material also, polypropylene is used. So this is example for polypropylene, and this all are example for synthetic polymers. So what is nature of this synthetic polymers? Synthetic polymers are non-biodegradable in nature, non-biodegradable, and also hydrophobic in nature. All synthetic polymers are repel water molecules, hydrophobic in nature, and resist to fire also. So these are important uses. But here one property is it is non-biodegradable. It is not decomposed in nature. So a few biodegradable polymers also there. So what is the synthetic biodegradable polymers? Generally, all natural polymers are biodegradable. What is synthetic biodegradable polymers? We'll discuss about that. So synthetic biodegradable polymers, one important use, that is the PHBV. What is PHBV? Uh, Polyhydroxy. The full name is polyhydroxy butyrate co-beta hydroxy valerate. This is example for PHBV. Polyhydroxy butyrate and co-beta hydroxy valerate. What are monomer units and what is the nature of this? It is a biodegradable polymer. What are monomer units of PHBV? PHBV monomer units are what is that? 3-hydroxy butanoic acid plus n number of 3-hydroxy pentanoic acid. So these are the monomer units of PHBV, 3-hydroxy butanoic acid and 3-hydroxy pentanoic acid. These are involved in condensation, polymerization reaction. So we'll discuss about the structure of this. So 3-hydroxy butanoic acid. But means the 4 carbons are present. 4 carbons are present in butanoic acid. So first we start with the 3-hydroxy butanoic acid. So but means 4 carbons are present here. This is COH group and this is OH group. This is CH3 N number, CH, CH2. This is polymerized with N number of 3-hydroxy pentanoic acid. Pent means 5 carbons are present and third position hydroxy group is present. Here, hydroxy group is present. N number of molecules are present here. So we get this type of polymer. CH2, CH3 by losing of water molecules CO. This type of polymer is formed in this reaction. This is called as a PHBV. So what is importance of PHBV? PHBV used in it is a biodegradable polymer. It is used in capsule covers, capsules, and also it is used in mainly used in orthopedic devices also. This PHPV is used. Next type of polymer is polymethyl acrylate. Polymethyl methacrylate. One more important polymer. So what are the monomer units here? CH2 double bond C. And bottom side, what type of group is present here? CH3 group one side, and one side ester group is present, OCH3. This is the name is methyl methacrylate. N number of molecules are combined here. So here it is double bond is involved in addition polymerization. So we get CH2, CH, COO, CH3, CH3 with n number of molecules are involved here in polymerization process. This part only involved. So we write like this COO, CH3. This part is involved in polymerization process. Okay. So what is the use of this methyl methacrylate? Here it is used in transparent domes, and also it is used in glass industry also. What is that? That commercial name in that glass industry, and windows of planes also it is used. Windows of planes also it is used. What is the commercial name of this windows of planes that is called as a plexiglass. You can call it as a plexiglass, or perpex also we can call. These are commercial names of this polymer. So these are important polymers used in industry, polymerization industry. So few are synthetic polymers and few are natural polymers. We'll discuss about one more natural polymers also. One natural polymer completed, that is PHBB. One more also there, polyglycolic acid. One more is polyglycolic acid. So what is this polyglycolic acid? So it contains glycolic acid, OHCH2COOH. It is called glycolic acid. N number of molecules are present and it is heated. It loses water molecules. So we get this OCH2CO with N number of molecules. Here it loses water molecules. So this is a polyglycolic acid. What is important use of this polyglycolic acid? It is used in stitches, post-operative stitches, which are decomposed in nature. That is what is it is made of. What type of polymer that is called as a polyglycolic acid. So these are importance of important natural and also synthetic polymers. So